Right, so welcome back, grade 11s. We're moving on to chapter 2.3 now. We're skipping chapter 2.2. So 2.3, the internet and the World Wide Web, WWW. Right now, first of all, let's start. What's the difference between the internet and the World Wide Web? They're going to explain, oh, here we go. They explain it. Very important, they're not the same thing. Okay, the internet refers to the physical network, the actual cables that are under the ground, the telephone cables which connect us to telecom, to our internet service providers, the fiber optic cables which are buried underneath the ground, and also which connect South Africa to other parts of the continent and to other continents around the world. Also, the wireless transmissions that go out over the internet. All right. So that's the internet. It's the actual physical network. On its own, the internet doesn't give us anything. There's no games on it. There's no information on it. It's just a network which does nothing on its own. Now, on top of the network, we have the World Wide Web. What is the World Wide Web? It's basically a service, a compilation of different websites, different services and content that uses the network for us to be able to access it. So let's use an example, YouTube. We watch videos on YouTube, all right? So YouTube has a server somewhere, multiple places throughout the world, where they store all of these videos. Let's use America again for an example. So you want to log onto YouTube and you want to see what videos you can watch, and you want to watch one, you have to connect using the internet to America, where these videos are stored on the servers, on the hard drives there. Then you access what you need to access, send it back to you, and then you can watch it. Okay, so the internet is kind of like your means of getting there, and all the different content available, all the websites, things like that, that's the service, the World Wide Web that we use on top of the internet. Right, the evolution of the internet. So we have type of internet connections. We have our fixed location internet access and our mobile internet access. Here underneath fixed location, they're talking about you have an internet connection to your house. You can't take that internet connection somewhere else. So I'm talking about your ADSL, which uses your telephone line, or fiber optic connection, which is literally dug underneath the ground to your house. You can't pull that cable up and take it with you, so it's fixed. Mobile internet access refers to your 4G, your LTE. So even though you might have an LTE router which is at home, you can pick that router up. Usually it looks like a USB. Go somewhere else and you can use it there because it's using a wireless connection to the nearest cell phone tower. It's not using a cable underneath the ground. Okay, so that would be mobile. Right, now, when we talk about Web 1, Web 2.0 and Web 3.0 over here, these are the different generations of the internet, the evolution of the internet. So if we start at 1.0, this is even before my time. We're talking like 1980s, 1990s. This is the early stage of the internet, or sorry, the World Wide Web. Let's be specific, that's my mistake. The internet, again, is the network. We're talking about the service, the web pages on the internet. So we're talking about the World Wide Web. So version 1.0, here we have static web pages with hyperlinks. Static means that it doesn't change. If you look at Facebook today, as you scroll down, it's changing. Somebody presses like, automatically on your screen, another like appears. It goes from 10 to 11. So that's dynamic. Static means once you've loaded that web page, that's how it is. It's not going to change. So there's no moving things. There's no pictures that change. There's no video. It's just text with hyperlinks. You can click on a link to take you to another page. They're not frequently updated. and there's few content creators on the internet at this stage. Then we get Web 2.0. This is now more or less where we are today. So our web pages are dynamic and content can be added by the user. So we can update our status messages, for example. Users can become content creators, not just content consumers. So I watch YouTube videos, but I'm also making a YouTube video, right? So I'm creating content. Also, yeah, they have wikis like Wikipedia. You read Wikipedia, but you can also add to Wikipedia. Social networks like Facebook allow people to link up and keep in touch. So that's Web 2.0. It's more dynamic. It adds more functionality for videos. Anybody can add to the internet. You don't have to be some big company. I can add a blog. I can create my own web page. You know that annoying advert that pops up all the time, Wix? You can make your own web pages, things like that. So that's Web 2.0. Then we get to Web 3.0. And arguably, we've already started to transition towards Web 3.0, but we can't necessarily say that we're there yet. There's still a few things missing. So we have Web 3.0 will be fueled and driven by a high-speed, high-bandwidth internet connection. Now we're on our way there. In other parts of the world, they've had this and they have it for a while already, but look, I'm going a bit off the book here, just bear with me. 5G is said to be the herald now of Web 3.0 because LTE is fast, but for the complete Internet of Things experience, for complete Web 3.0, we need super fast internet, right? And so 5G is hopefully going to be that means. An ever-widening range of devices will be connected to the web. This term, the Internet of Things, has already been coined in this regard. So what do they mean by the Internet of Things? Well, quite literally, as it says, today we have our cell phones, perhaps we have smart watches that connect to the internet. But what about our TVs? Already done. What about our fridges, our toasters, our beds? What about our entire house connected to the internet, talking to the internet, providing things, information about us, for us? So this is the Internet of Things. Now, you might think, but why would I want that? Why do I need my fridge to be connected to the internet? It may happen that a fridge learns, we call it like machine learning, algorithms, learns what you usually always have. Like for instance, there's always milk in my fridge because I use it on a day-to-day basis. So the fridge can assume that the milk needs to stay up to date. It needs to always be there. If it's running low, we might get a little ping on our cell phone saying milk is low. What happens if I want to create a shopping list? If I want to do that today, I manually have to walk around the house and I have to look what is running low, type it into a note or something like that, and then I can go off to the shop. What happens if I just go from work, I just go straight to the shop, and I look at my phone and there's a shopping list that my house or my fridge, my cupboards, processed and created it for me to say that you're running low on cereal, you're running low on milk, there's no pet food, things like that. And so I know what I need to buy. I didn't even check. This is the Internet of Things. And it sounds lovely. It is lovely. But it's not here just yet. So that's why I said we're moving there. We have 5G now. We have the necessary internet connection. It's coming, but it's not quite here yet. Okay, you can just read through that. Will not be limited by incompatibilities between hundreds of different hardware and software applications. Okay, blah, blah, blah. Just read through that. There's a summary. Right. Multimedia. So downloading versus streaming. When I was smaller, we didn't stream because we didn't have the internet speed, and we also only had like 1 GB of internet cap. I remember those days. Today, that's not a problem. Today, you want to watch a movie, assuming that you paid for it, you can just stream it. You don't even have to download it. Now, what does it mean to download something? It means you download the entire file and you save it on your computer. And later on, you can watch it or read it or use it, whatever it happens to be. When the internet is disconnected, no problem, because it's on your computer. You've literally taken it, downloaded it onto your computer. So it's there whenever you want it. However, to stream something means that you don't necessarily download and save it. You take what you need. So you do download a bit, like in the sense that you download it onto your computer, you consume it, but as soon as you close it, it disappears because you didn't save it. You just temporarily took it, you consumed the movie, you watched the movie, and now you don't need it anymore, right? I'm not going to watch the movie again. I watched it, now I'm done with it, and so it goes. A good example of this is YouTube. Does it make sense to download and save in a folder on your computer every single YouTube video that you've ever watched? No, because you'd completely use up your entire space, right? That doesn't make sense. So rather we just watch it. The internet, we're downloading the information to our computer, yes, so that we can watch it. But as soon as we're done watching that, it's gone. We close the browser and the video is gone. It's not saved on our computer anymore. So that is streaming. Live broadcasts, right? This is when you watch something live. Perhaps some of you guys are familiar with Twitch, where you watch somebody play games, you interact with them live, or you're watching a live soccer match, or a rugby match, etc. Video on demand and internet protocol television. Okay, just read through that. Compression of media files. Okay, this is another important part. Compression is very important today because we have so much information that transferring our information from one place to another place, if we don't have some means of compressing it, it's going to take a lot of space on our hard drives, and because it's so big, it's going to take a long time to transfer from point A to point B. Okay. So we can compress these files to make them smaller so that they take up less space and we can store them on our cell phones and things like that without taking up unnecessary amounts of space. Now we have two types of compression. We have lossy compression and lossless compression. They're different from each other. Let's look at lossy. Compresses data by losing some of the data. That might sound bad, but there's a good reason for that. It works because human eyes and human ears are not that good. Okay, they're pretty good, but they're not perfect. For example, you can take a sound file and you can cut out the high tones and the low tones that a normal human ear simply will not be able to pick up. Okay? You know that there's certain frequencies perhaps that other animals, for instance, they can hear them, but we can't. Like for instance, let's look at a bat. Can you hear a bat's echolocation? No, you can't, but they can, right? So it would be useless to have frequencies of sound that high or that low. So they just cut it out, they make the file smaller, and everything that we care about is there. Also, okay, now let me not go into too many examples over here. Let's move to lossless compression. This is compressing the data without losing any of it. Now, there's certain cases where we cannot afford to lose anything. So, example, let's see here. Documents or emails or spreadsheets or databases or pictures. If we lose some of the data in there, we're going to have sentences with missing words. We're going to have pictures with black spots in it because that part of the picture was simply lost. And who wants to compress a file if it's going to completely destroy it, right? So different scenarios call for different types of compression. Let's go further. MP3, MPEG-2, MPEG-4, and JPEG. These are the types of compression that we're going to look at. There are hundreds of others, but we're going to look at these few. Now, MP3, which is part of the MPEG-1 audio layer 3 compression standard. This will be familiar with you because you usually think of songs and tracks. So MP3s are normally 1/10 of the size of the uncompressed file. So imagine that you can save 10 tracks on your cell phone or your iPod or whatever instead of just one. Right? So clearly you can see the benefit of that. MP3 files are normally 1/10 the size, but they retain the same type of quality that we can pick up. Their small size is good for downloading, storing, and sending from person to person. Here we have other two types of video. You can read through those. I'm going to jump to JPEG, which, if you are familiar with this, will make you think of pictures. So JPEG is the most common file used for digital photos or graphics. JPEGs are also known as JPG files. They use lossy compression, and therefore the file size decreases. Image quality also decreases. The trick is to get a balance between quality and file size. Okay, so we can have a huge picture, which let's say that the picture is 50 megabytes, which is massive, and it's super crisp quality. But I mean, we're going to be looking at this picture on our cell phones, which is a small screen. Is it necessary to have a picture which is literally the size of a wall? No. So we can compress it. We can use a JPEG compression formula to compress it to a smaller size so that it first of all doesn't take up all our space on our hard drive on our cell phone. But at the same time, we mustn't compress it too far so that the quality becomes so bad that we don't even we start missing some of the picture. Right? And I think that's it for 2.3.